So remember how the other day in the examples, we just basically have to identify that there are triangles with three, or shapes with, triangles with three of the same angle. Here, I would have big triangle and little triangle. Okay, oh, that's really badly drawn. I can see that this angle is the same because that's the one they've drawn in. So that's check. I know that this angle here is obviously the same because that's the same angle. And then why would these ones here be similar? How do we describe these angles?
180, so it has to be the same.
Oh, okay, you can say that. Yeah, you can say that. But these angles here, these lines here are parallel to each other, so these are corresponding.
Vertical opposite.
Oh gosh.
Well,
Well, you just have to show that they have three angles of the same amount. You don't have to know what they are, but you know that they would be the same because they're corresponding.
we understand.
All right, next one. Next one. They've told us that these two angles are the same. Check. What's special about these two angles? They're vertically opposite. Love it, love it, love it. Love your work. And therefore, these ones here, now, we wouldn't say these are alternate because there's no parallel lines here. But we would know that they are equal because someone just said, if we've got two angles the same, the third has to be the same anyway. Okay, so essentially we only really need to show that there are two equal because we know they add up to 180.
I have a name. No, that was me.
Actually, a couple of people have said it earlier.
Well, it's like someone, like a singular.
Oh my goodness. Okay, this one here is very similar to this one. Do I have to talk about it again?
No. Yeah.
These are corresponding. These are corresponding because these are parallel lines. And then this angle here is the same. Tresbians. We don't know anything about these lines here. If they've got the arrows on it, we know they're parallel. But they have said that this angle here is 24 and this one is also 24. We know that, oh, wrong one. These two have to be the same because they are vertically opposite. Therefore, the others would be equal as well.
Ms. Harrison, are those ones also alternate like that?
Yes, these would be alternate. So it does actually also indicate that these are parallel because if those two angles are equal to each other, it means that these must be parallel lines. Tresbians.
Wait.
Oh. So calculate the missing lengths. So we know they're similar triangles. So x. Oh, that's so not an x. Oh, shush now. So x divide. Okay, which triangle is corresponding to x? Would be equal to what? Now here you got to be careful.
3 over 5. No. 5 over 3. No. 6 over 3 over 5.
All right. No. Okay. So this has highlighted. This has highlighted a good thing to do is to just redraw your shapes next to each other. Okay. Now my small triangle is 5 and 6. So this is x. Now what's this length here?
3. 8.
Be careful. It's this whole length.
That one's supposed to be bigger. I know it's hard to tell. But
Okay, so that would be 8. So we would now be able to set up an equation. X over 6 is equal to 8 over 5.
Yay.
So x equals 8 over 5 multiplied by 6.
Harrison, that's an A.
Where?
It's an A over 5.
No, it doesn't. It's an 8.
That's an 8.
Yeah. It's an A.
Well, it means girl. It does
Oh,
not.
I see.
Well, now it looks like some bumblebee or something. I don't know.
Okay, so it's 48 over 5, which is 9 3/5.
Yay!
Okay, next one. Again, two triangles. Let's just do a quick baby sketch. So we've got 7 here, we've got 5 here. What do we have on the bottom here?
8.
And x. So unknown divided by
5. 7.
7 would equal
8.
divided by
5.
5. So x is equal to 8 over 5 multiplied by 7, which is
56.
over 5, which is 11 and 1/5. Tresbians.
Yay! Oh.
Okay, leaning against the wall, same meat, different gravy. I can't be bothered to do this one.
Yay!
So if we're trying to find how far up the wall the timber reaches, we're trying to find this measurement here. And you would just do it in the same way, yes? They're all very, very similar.
Wait, can I say a message?